you're hearing Wolf Eyes by the musician Paul Winter. One of the things that Paul has done over the years is sample the sounds of animals. A wolf in this instance, but whales and thrushes and all kinds of things. And then try to make music that sounds like them, that tries to mirror their tonality. So we're going to be talking very specifically, though, about those sounds that animals make and to what degree they can be considered communication, to what degree they could be considered maybe to have a syntax, maybe even to be a language, maybe not, as you will hear. Our guest for the first two segments of today is Arik Kirschenbaum, professor of zoology at the University of Cambridge and author of Why Animals Talk, the New Science of Animal Communication. So first of all, Arik, welcome to our show, and we can play you one of your own sampled wolf howls if you want, but you heard that one at the top of the show. Maybe just react to it, sort of walk us through your method of interpreting, understanding something as primal as the howling of a wolf.
Well, thank you. Thank you for inviting me. Yeah, it's great. Great to be here. I love it. It's great, isn't it? These sounds do have a tremendous emotional effect on us. And it's not unreasonable to assume also that they have an emotional effect on the animals as well. That's what they're for, after all. That's what communication is for changing the way another organism behaves or understands the world around them. So when we hear howls like that in the wild, I mean, most of our research, most of the actual attempting to figure out what's going on involves tying different sounds to different behaviors. So many times it's really important to know not just what sounds the animals are making, but also what they're doing while they're making them and how other animals respond to them.
So that wolf was howling. One of the things we can reasonably infer about that wolf is the wolf is alone at the time. Wolves have a lot of ways to communicate when they're with each other, and they spend a lot of time with each other. If they're howling, correct me if I'm wrong, they're probably alone, and that has something to do with the quote-unquote content of that howl.
Well, that's one reason that they howl, and one time that they howl is when they're alone, for sure. You know, when you're a wolf and you're out in the wilderness in your pack and you are separated from your pack, you could be quite a long way away. It's important to have that way of staying in touch, getting back together. But wolves also howl together. When they are together, they will often howl in a chorus. And in fact, when wolves are together and one of them starts howling, it's almost inevitable that all the others join in. It's almost irresistible to them.
And we see this a little bit. I mean, I don't want to, project too much onto our own pets, but if you're a dog owner, there's a good chance that if an ambulance goes by, I walk my dog with about 10 other dogs in the morning, and if an ambulance goes by with its siren wailing, some of the dogs are going to howl because they are imitating that howl. There are dogs, obviously, who react to certain notes on the piano that way, too. So that's wired in somehow, right? You hear a noise, you make a noise kind of like it.
Well, it can be actually a little bit more complicated than that. In fact, when wolves in the same pack who are all together at the same time and they hear each other howling, they start howling. That's very much a sort of social, communal response. When a dog hears an ambulance going by, that might be something different. That could be, for instance, reacting to potential intrusion into their territory, which is another reason why wolves howl. So they'll howl when they hear members of their pack howling because they like to howl together. But they'll also howl when they hear members of another pack howling because that's a potential intrusion into their territory.
So let's play another wolf howl. This is your sampled wolf howl. So this is A1, Maestro. Let it rip. So there's tone there. Can we talk a little bit about that? Is it possible to map meaning onto changes in tone?
Well, the first thing that's immediately obvious from that howl is that's a North American wolf. North American wolves have this habit of shifting their pitch up and down a lot, and something that you see much less in European wolves, for instance. Now, why they do that? It's a really good question. I think that there can be information in that pattern of switching pitch up and down, up and down. Certainly there's potential for information there. Whether the wolves actually use it or how much they use that to identify concrete meanings, that's another story, not quite so easy to untangle.
But we want to untangle that, right? I mean, and presumably the tonality of a wolf howl when the wolf is saying, hey, I got separated from the pack, I'm over here, is different from when the wolf is saying there's some other wolves coming over and they're not part of our group and they're going to want to take our stuff. I mean, we want to be able maybe to discern a difference like that one. Is there a way to do that?
Yeah, absolutely. We want to, and this is one of the things that I do. This is one of the things that I work on. It's true that those wolf howls are really designed, that they've evolved for long distance communication. And when you have long distance communication, really the only way you can distinguish two signals is by the pattern by which they go up and down in pitch. So the fact they do go up and down in pitch implies that there's different information they need to distinguish. Which howl or which pattern of howling means I'm lonely, and which pattern of howling means there's some enemy wolves coming into our territory, that we don't know yet. We don't have a simple answer to that yet. It's really difficult to figure out, actually.
So part of your the theory, that one of the guiding ruling theories of this book is kind of tell me what living conditions the animal has, and I'll be able to tell you more about what kind of communication they need to do. And that's the kind of communication they need to do. So, for example, wolves, as you point out, need to be in packs most of the time. They're not able to hunt the prey that they want on their own. They need at least 4 of them, but they need more of them to keep other animals from coming and getting all that stuff. It's a societal animal. Tigers, not so much, and not only that, but tigers don't have as many things that can hurt them or be a problem for them as wolves. Tigers tend to be the problem for everybody else. So presumably they don't need a quote-unquote vocabulary as elaborate as wolves do?
Absolutely, yeah. That's a really good summary. I think that communication has evolved to influence the behavior of other animals. That's what communication is. And the more other animals that you're working with on a day-to-day basis, the more things you have to say, the more things that you might need to say, particularly because societies are really complex. When whether you're a wolf in a pack, even in a wolf pack where most of the animals are probably quite closely related, but there's still a lot of tension, there's conflict, there are behaviors that need to be mediated and changed to keep things running smoothly. So yeah, it's the ones with complex societies that have complex communication.
So let's switch animals for a second. One of the things that I think blows everybody's mind when they read this book is that the idea that at least one animal has what amounts to a name the animal has more or less chosen for itself, a name that is different from the names of other animals in its species, the animals that it would encounter. I'm sort of like doing a big reveal here. I'm not saying what animal it is, but let's hear that animal A2, Maestro. So that's a little tiny bit of dolphin. And so explain this idea. I mean, I don't know if names are exactly the right term, but close enough, right? They have a kind of audio signature that is just that one dolphin.
Yeah, it is. It's pretty clear that these are names. It's not a common phenomenon. It's true. It's really rare in the animal world for animals to give themselves names, and we think possibly elephants do as well. But it's very unusual. And it's the sort of thing that you would expect to evolve in those societies where knowing who you're talking to, knowing who you're with, is really important. Think about living in the sea. Think about being a dolphin. The sea is vast, right? You could be anywhere, and everyone else could be anywhere. And so, finding the right individuals to collaborate with, cooperate with, work together with, or avoid is really important. So, one of the reasons that names are a sort of sensible evolutionary innovation for dolphins is that they have this very complex, very fluid society where everyone's always swimming around and breaking up and coming together. But the other thing about dolphins that makes names a more reasonable assumption for what these special sounds are is that dolphins have this really advanced cognition. They know about individuals. They know what an individual is, and very few animals can do that.
I think also what's interesting about this is the same thing that makes dolphins, or what are the conditions that makes dolphins need to be able to specifically identify themselves to other dolphins, and maybe a little bit of what we said about wolves too, is tied to the difficulty experienced by people like you, Eric Kirschenbaum, in studying these animals. These are not animals. You can't study their behavior in their natural environments very easily because dolphins and wolves in very different ways just won't stand still for it.
Yeah, it's what makes the field so interesting sometimes, but it also makes it extremely difficult. So, you can't put animals in a maze and expect them to behave in a natural way. You can't put wolves in a zoo and expect them to behave in a natural way because these are animals that are used to roving over vast areas, competing with other packs if there are no other packs, and they never get separated from each other more than the length of their cage. They're not going to vocalize in the way they would in the wild. But dolphins, very much so. I mean, just being underwater and, and watching a dolphin swim away from you can't keep up with them. So they're incredibly difficult to study. That's what makes it interesting.
Yes, because I mean, the other thing is the minute you get them in captivity, animals will tend to be eager to please, particularly if they know that some of the things they want and need are available to them if they are pleasing. So right away, I mean, we're going to be talking at the end of the show about the efforts now to study dogs pushing buttons and things like that. But dogs, they want to please us. So we're kind of speed dating through the animals of Eric Kirschenbaum's work. So we're going to go over to Vietnam now and visit a gibbon. This will be A3 Maestro, and I'll probably fade it because, let's face it, gibbons are kind of long-winded. Here we go. So, Eric, you might have to remind some people what gibbons are. They're a primate, but you may say a little bit more about them.
Yeah, gibbons are apes, so they are relatively closely related to us. Diverged, our sort of ancestry diverged from gibbons about 20 million years ago. Compared to that, we diverged from chimps about 6 million years ago, our closest relatives. So they really do share a lot in common with us. They live in the jungle, they're in the forests. Their sort of trademark ability is to swing. They've got really long arms, and they swing under the branches rather than walking along them as monkeys often do. So they're part of this evolutionary pathway that led to humans. And so their communication and their cognition, the way their brains work, is really, really interesting.
So they have these songs that they sing, and that's what you were hearing here. I mean, we're calling them songs. Who knows how they think about this? But this is their communication. Once again, it's kind of tonal in nature, durational, sound-specific, and it's complex. It's maybe more complex than an awful lot of other animals. Can you say a little bit more about what is detectable in all that complexity?
Yeah, so these songs are mostly duets between a mated pair, so a male and a female, singing back and forth to each other. But they're also used for other purposes. They're used as warnings, warnings about predators, warnings to other gibbon groups that they shouldn't intrude on the territory. And because of that complexity, because of that incredibly detailed potential for complexity in these songs, there's a lot of information that you can fit in there. Now, how much information actually is in there, that's another story. We do know that white-handed gibbons, different species of gibbon, can distinguish between different types of predators that one of them has spotted from the kind of songs that they give. But more likely, it's a lot to do with the nature of the group and who's in the group and how well matched they are.
Yeah, let's kind of dig down a little bit on what you were just talking about, because in the book has all this fascinating stuff in it. But one of the things you do is you kind of analyze the songs that gibbons might sing to react to and warn others of an incoming predator. And the leopard song is different from the snake song, etc. Although, and this is why I said they're long-winded, I was reading that and I was looking at the diagrams and stuff, and I was thinking, wouldn't it be a lot more efficient just to go leopard, 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 leopard? But they don't seem to be doing that. They seem to be telling us a longer story about what's coming. And this is probably the most important kind of communication, except for maybe being able to make other little gibbons. This is the other really important kind of communication they need to do. So I don't know. How do you see all that?
Well, alarm calls are, as you say, they really should be immediate, short, very specific. And that's what we see in most species. But there are quite a few species, primates and some birds, that give really complex alarm calls. And like you say, at first glance, that seems a little unusual. Just say, run away, or, run away up the tree if it's a leopard, run away down the tree if it's an eagle, or something like that. But it should be short and sharp. Oftentimes, though, what's happened is that these alarm calls have multiple parts. The first part is a general alert. So it's like, okay, important public service announcement coming. Second part is the nature of that alarm: leopard, snake, eagle. And then the third part oftentimes has to do with the intensity, with the nature of the urgency. So sometimes going on and on and on might mean that it's more urgent, might mean that you should pay more attention to this. Don't forget, animals are surrounded by predators all the time. Think of the zebras and the lions and the savannah. They're always there, but they're not always hunting. So you need a way of distinguishing how you assess the risk in a particular situation, and that's where you can put a lot of information into these calls.
All right, that is fascinating. We're going to take a little break here. Well, we're going to come back with more of Arik and his work. So here we go.
Cold Cape Cod clams gainst their wish, do it. Even lazy jellyfish, do it. Let's do it. Let's fall in love. Electric eels, I might add, do it. Though it shocks 'em, I know.
If I could talk to the animals, just imagine it, chatting with a chimp and chimpanzee. Imagine talking to a tiger, chatting with a cheetah. What a neat achievement it would be. If we could talk to the animals, learn all their languages.
We are talking not talking to a non-human animal. We're talking to a human named Arik Kirschenbaum, professor of zoology at the University of Cambridge, which means he probably thinks I should have played the Rex Harrison version of that song, and author of Why Animals Talk: The New Science of Animal Communication. So the book is really, it does take two different paths. One of them is everything we've been talking about so far, how animals communicate with one another. But there are, of course, efforts made to create lines of communication between non-human animals and us. And one of the really interesting instances of that is with parrots. So, Arik, parrots, and maybe particularly African gray parrots, have become almost celebrities, particularly one of the ones we're going to talk about pretty quickly here. Say a little bit about what kind of research, what kind of study has been done of that.
So parrots are great fun because you can work with them in captivity. It's extremely difficult to work with parrots in the wild, of course, as with most of these species, but they do thrive in captivity. And rather like dogs, like you're going to be talking about later on, can form social bonds with humans, and that allows a back and forth interaction over a long period of time. So what in particular Professor Pepperberg did at Harvard was train a number of African grey parrots to learn language, to understand, to see if they could understand some of the sort of fundamental concepts of what human language is. Now, what human language is far more than just being able to respond to a stimulus. So if you tell your dog to sit or to heel, that is not understanding language. That's responding to a very specific stimulus. But these parrots, they could do a lot more. They really could.
Yeah, including, I mean, we'll just get to one of the more mind-boggling examples of something that Alex, the African gray parrot, could do. So you could show Alex, let's say, 3 plastic green squares and 2 plastic green circles and ask Alex, what's the difference? What would his answer be, Eric?
In that case, his answer would be shape.
And he did give that answer too.
Indeed, yeah. Oh, absolutely. And it's almost impossible to see how anyone could give that answer without understanding the language of the question. This is not something that can be learnt by rote. It's not something that can be trained. It only comes from a linguistic understanding. How a parrot could have that ability, it's pretty amazing.
Yeah, I mean, I've seen some of these experiments where the parrot is presented with a bunch of different shapes and different colors, and the researcher says, pick out the blue triangle. And so the parrot picks out the blue triangle. But that involves, I don't want to say just, but that involves just being able to figure out which ones are triangles and then which ones are blue and where the overlap is. Saying shape just seems to involve a kind of categorical thinking that, and an abstract thinking that is a little bit startling, Eric.
Oh, yeah. And in fact, there are very, very, very few animals that can do that. Pretty much every animal can learn to recognize blue. Training animals, conditioning animals to respond to specific stimuli works really well. And you can train chickens and ants and things. It's a very, very widespread ability, which makes sense when you think about it. Animals have to solve problems in the wild and they learn from their environment. That all makes a lot of sense. Why an animal should have this very, very conceptual ability, still a bit of a mystery, to be honest.
So before you wrote Why Animals Talk, The New Science of Animal Communication, that's the book we've been discussing today, you wrote a book called The Zoologist's Guide to the Galaxy, which deals with a question that we've dealt with on other occasions on this show. It's one of great interest to our senior producer, Lily Tyson. I'm not entirely sure I know why that is, but and that is, let's say, a newly arrived species comes here, a highly intelligent species, because how else did it get here? And we are going to want to be able to communicate with it. It's very much the plot of the movie Arrival, among other things. And so, you can sort of, I think, extrapolate from Alex the parrot and all the things that could be understood by Alex and maybe about Alex and the kind of communication that could be exchanged. It's not irrelevant to the question of how to communicate with a form of life from some distant galaxy.
Yeah, there are people that I work with who believe that the best way to prepare for communicating with an extraterrestrial species is to see whether we can communicate with non-human animals on Earth. There are some good arguments to make in favor of that. There are some drawbacks to that as well. And really the issue is, are there any other animals that have a true language? Because when that alien species comes to Earth, comes and visits us in their fantastic spaceship, we can be pretty confident they have a real language. Otherwise, as you say, they wouldn't have been able to build that spaceship. No one can build a spaceship on their own. So at least we know we will share with them language of some sort. And what's not clear is whether any other animal species on Earth, not whales or dolphins or parrots, whether they have a language of their own. We think at the moment, probably not.
Yeah, but we have to make sure, by the way, first, that they're not the equivalent of Laika or whatever the name of the Russian dog was that got sent up on the first spaceship. It could be the really smart extraterrestrials are thinking, good, you, whatever you are, get on there and we'll see how you do. But I think the other part of it, using Kirschenbaumism as my guide, I would say, well, so much of the product of any species' vocabulary or ability to communicate has to do with the environmental challenges that species faces, and where they live and what they interact with and stuff like that. And we won't know any of that about an extraterrestrial species. I mean, the stuff that's really interesting to them is going to be stuff that we've never seen and might not be able to imagine.
Yeah, but you've got to remember that once a species evolves language, then all of that changes because, yes, it's true that wolves, their communication is based around their lifestyle, and dolphins' communication is based around their lifestyle. And I think we can safely say that our communication now, what we're doing right now, isn't that related to our biological needs, right? Once you have language, communication just sort of takes off, and it's that infinite, unbounded ability of language that gives us the power to build spaceships. And I think we will have that in common with any technological alien civilization that we come across. So I'm not so worried about that. I think that one way or another, we will recognize that in each other and be able to teach each other our languages.
Yeah, it's kind of the point that Harari makes in Sapiens, that this particular species, Homo sapiens, can think and talk about things that it can't see, things that are, invisible to them, which is, I think, pretty difficult for most animals. Invisible, inaudible, indetectable. It can still be thought about and discussed anyway. All right, I've saved the best for last, at least from Arek's point of view, because I can tell he's getting a little gloomy because nobody's asking him about hyraxes, and he likes hyraxes so much. So first of all, we'll explain in just a second what a hyrax is, because most of you don't know. But let's begin with the enchanting noise of the hyrax. B2, sir. So these are rodent-y kind of things. They look a little bit like a groundhog or a prairie dog or a guinea pig or something. And explain why they are of interest to you.
Okay, well, they're not rodents, in fact.
Okay.
They're more closely related to elephants, but nonetheless, they are small, furry mammals, and they live in large groups, one male and a bunch of females, and they don't do very much. Right? They eat and they run away and hide from predators, but basically, they live pretty simple lives, and their communication needs are pretty simple. And yet, their communication is so complex. They sing these long songs. It's the male usually who sings the song, the dominant male. Long, complex songs. Now, we're pretty sure that the reason for that is the same reason that birds sing songs. They're attracting mates and scaring away other males. But does it need that complexity? Why are they so complex? And this is something that gives us a nice little window into some of the processes that led to the evolution of language itself.
Yeah, and I think also this is also leads nicely into the third conversation that after you depart, we'll be talking about these dogs pressing these buttons. The question is, are the dogs selecting a series of words that create a kind of syntax, a kind of order or suggestion about the meaning of the words, how they exist in a sentence format. And I'm not doing a very good job of describing syntax. And a lot of it depends on the language, too. I mean, in Latin, you can say the soldier killed the farmer in kind of in any order you want, because the case of the nouns tell you who killed whom. But hyraxes seem to, if they've got 5 sounds, they use those sounds in particular orders and with particular frequencies as if they had some kind of syntax.
Yeah, what's really interesting about them is they do seem to pay attention to the order of the sounds. Now, we don't think that there's lots of different meanings in their calls. They're not saying the farmer killed the soldier and the soldier killed the farmer. No, they're just saying, I'm a big, strong male hyrax. Come and mate with me if you're female, or stay away if you're male. The same message over and over again, but they pay attention to the syntax. And what this tells us, which is really interesting, is that understanding syntax, understanding that the order of sounds is important, seems to be a very, very widespread ability in animals, much more widespread than we thought. We tend to think of syntax as being something that only humans have, but no, a lot of animals understand it.
So I guess, as we're nearing the end of our very enjoyable conversation, we played that little song from Dr. Dolittle, and I guess people wonder, will we ever be able to, in fact, talk to animals? That will we have a broader and more specific and very reliable understanding of what non-human animals are saying? Give us your take.
Well, we do talk to animals, of course. We talk to our pets all the time. They understand us. We understand them. you ask whether we'll ever have a more specific conversation with them. And that really hinges on whether they have specific conversations themselves. Now, it's really important not to impose our own existence upon other animals. A dog is a dog, and we want a dog to be a dog. You don't want a dog to be a furry human. They have their way of communicating. They have their way of thinking. And if that does not involve the kind of specific concepts that we're so used to from our language and specific ways of combining concepts that we do in our language, then then we shouldn't even want to communicate with them in that way. We should communicate with dogs as they are, as dogs are. And I think with most animal species, that is going to be less specific, more general, more emotional, more broad stroke than the kind of thing that we're discussing between the two of us now.
Yeah, it's, well, Wittgenstein famously says, if a lion could speak, we wouldn't understand it. But it has been enjoyable to speak to you, Arik Kirschenbaum. The book is Why Animals Talk, The New Science of Animal Communication. This has really been a fascinating conversation, and it leads us up to, and one of the reasons I wanted to play the Hyrax is because we are, when we come back from this break, going to be talking very specifically about dogs and whether or not they can do something that resembles syntax. All right, here we go. We're going to take a little break right here. Thanks to Arik. Get the book, and we will be back with more.
The monkeys stand for honesty, giraffes are insincere, and the elephants are kindly, but they're dumb. Orangutans are skeptical of changes in their cages, and the zookeeper is very fond of rum. Zebras are reactionaries, antelopes are missionaries, pigeons plot in secrecy, and hamsters turn on frequently. What a gas you got to come and see at the zoo, at the zoo. At the zoo, at the zoo, at the zoo, at the zoo,
Dylan produced Tech Show Today. Show producer, Lily. I'm trying to do it a little bit more like a dog pressing buttons. Yeah, in fact, Dylan Reyes, the maestro, is our technical producer. Lily Tyson, senior producer of the Colin McEnroe, produced this episode. We're very excited to welcome back Federico Rossano, an associate professor of cognitive science at the University of California in San Diego. So, this morning, by chance, I was out with my dog, Declan, which I do every day. I'm in the park, and the dog he likes to play with, that dog is not around right now, and so he went up to another dog he knows pretty well, Jojo, and he barked at Jojo, and people were kind of startled, and they said, why is he doing that? Why is he barking? And I said, oh, no, I want to play with Jojo, and Jojo needs to be sort of bullied into playing sometimes. So we spend a lot of time trying to figure out what our dogs are saying, and we often know just because of the context and our familiarity with them. But there's been a lot going on with this. Federico Rossano is here to tell us about something that is simultaneously a really fascinating animal study and experiment, and also kind of an internet fad. And keeping the two of them from harming each other is one of Federico's jobs. So welcome to this show, and tell us a little bit about this. We should say this is a study that you might not have wound up doing but for the pandemic. This was a study that the pandemic made possible, or at least it was easier to do during the pandemic than a lot of normal kinds of research you might have done. Explain what it is, though.
Yeah, so the study that we're talking about is a study in which we're training dogs mainly, but also cats now. And we're training them to use buttons to interact with humans. And the idea is that they can push these buttons to, for example, request for food or request to go outside. And what happens is that over time, some of these dogs start combining some of these buttons to produce things that look like sentences. Of course, we don't really know if that's what they are, but one of the reasons this thing kind of developed, and now it's the largest animal language study, animal communication study, really, in the world, is because of the pandemic. So what happened is that we couldn't collect any other data, and we were like, what are we going to do? And of course, people are home with their pets, and they would like to do things. And simultaneously, there were a couple of influencers out there that were trying to train their dogs with these buttons. These devices were used before with humans, non-verbal humans that could not speak. And so this thing kind of picked up. We were basically saying, oh, maybe we're going to get a few participants locally to engage with it. And this became a humongous citizen science study because people really wanted to connect with their pets, with their dogs especially, and they wanted to have some way of understanding better what they're thinking, just like you said about what is Dylan doing when he's barking at another dog? Why is he barking? And that's sort of one of the goals of this study, is trying to see if by looking at how they're using these devices to interact with humans, we can learn something more about what they're thinking and what they're experiencing and how they are navigating living with us.
All right, we're going to give the listeners a little sense of what that might sound like. This is a clip of a dog owner, a participant in the study. You can hear the owner talking with the dog via these buttons. C1, Maestro.
Treat. All done. Water.
Breakfast.
Treat. Do you want the dinner from last night? Yes. Hungry. Treat.
Now, Federico, when this was first dangled in front of you, this idea, you had some real skepticism about this. You weren't even sure you wanted to do a study of this kind. Explain what the skepticism was.
I most certainly didn't want to do it. Actually, I remember sending my colleagues 4 papers saying this is why we should not be doing it. And part of the reason was that there's a long history of trying to train animals with symbols and words. This actually started in the 20th century, and we tried to train them first with words, then with sign language, and then with devices not too different from this, but the target population were mainly primates, so chimpanzees and gorillas and so on. And that history is complicated because, of course, these animals were removed from their natural environment, often spending their entire life in a lab or maybe in people's households and trained for 8 hours a day. And, it becomes, these animals were often traumatized. And, because of that, many people were like, why we should not be doing this. And I didn't want to do it. I didn't. The difference between what was happening in the 60s, 70s, 80s, and now is that in the last 20 years, we've learned a lot about dogs' cognition and the fact that they're much better than the human primates at understanding human communication. They understand pointing better, facial expression better, what our emotions. And simultaneously, dogs are domesticated. They already live in people's households, so they're not suffering if they actually spend time with humans, and they're going to be motivated to interact with humans because they care for us. And so this different setup made it possibly interesting. Then the next issue was, how are we going to do it? Because, of course, we couldn't go into people's homes, and I didn't want to do it in the lab. I most certainly didn't want to take dogs away from their homes and bring them into a lab all the time. And so it had to be something that people could do and contribute data and science from ideally their own homes, right? So the more friendly environment where ideally they can shine and show you what they can do instead of trying to bring them in a very sort of empty and boring room with white walls and hoping that they're going to show us skills that maybe they have, but they're just terrified of where they are and they don't understand what's going on.
So, I mean, I have found this whole study fascinating, and many of you listening may have read the New York Times Magazine story, which focused very much on it. There are some other things to worry about. One of them is what I think people now are pretty familiar with, the so-called clever Hans fallacy. This is a horse around the early 20th century and late 19th century, a traveling, performing horse who seemed to be able to understand commands from the trainer and be able to execute even sort of little math calculations or something. It later turned out that Hans was doing something really amazing. It just wasn't the amazing thing everybody wanted Hans to do. Hans was reading incredibly subtle cues from the trainer, unbeknownst to the trainer, and figuring out what he was supposed to do, but just not the way it was being marketed, I guess. And so that's a worry too, right? I mean, dogs are really eager to please for the most part, and so you want to make sure they're doing what you think they're doing instead of doing something else.
Absolutely. That was actually our first concern, right? It's like when people say, oh, my dog already understands all these words. And I'm like, they were like, oh, they understand. My dog understands outside when I say, let's go outside. And I'm like, oh, maybe they can just see you put on your jacket and your shoes. And that's how they figure out you're going outside. And they understand nothing about the word. So we had to do a study on this, which luckily we did. And we published recently. And the basic idea was we wanted to go into people's homes. We had buttons covered with stickers so that the experimenter wouldn't know what they were pressing. And the experimenter had headphones on, and the owner was removed from the scene, so was in a different room so that the dog would not be looking at the owner for cues. And the experimenter was instructed before going into the room to just push buttons in a certain sequence. And for example, they would go in and push the button with the red sticker on. They had headphones on, there's music playing, they don't hear what is happening, and they just stand still and they see what the dog does. And then they push the next button, the one with the blue sticker on, and you see what the dog does. And then the videos are collected, and we remove the audio, and we use an ethogram to basically annotate what kind of behaviors did the dog have. And it's coded by people who were not in the house, did not see what was happening live, and they are randomly ordered so that you're not seeing them in a sequence to kind of pick up, or maybe it must be this or it must be that. And what we see is that basically dogs are paying attention to words. And if you say, when they hear the word outside from the button, they respond in a contextually appropriate way. And when they hear the word play, they go and retrieve a toy so they can play. Now, interestingly, we tried to do the same thing with the owner, where the owner would push the button and we see what the dog does, and the owner would just say the word and we see what the dog does, and the behavior is exactly the same. So for us, there was evidence that at least these dogs that are engaged in this study, and the most proficient one for sure, they are not just reading human facial expressions and so on, but they're actually listening to the words and reacting to them in a way that makes sense contextually.
So, the next step, though, is what's happening when dogs create their own responses. My favorite moment from that New York Times Sunday Magazine article, which I read on that day, was the dog who was frustrated with its owner because the owner wasn't. I think it had something to do with daylight savings time. The dog thought it should get fed. The owner wasn't feeding it. The owner was saying, wait. And at a certain point, the dog clearly was just vexed and really wanted its food and used the buttons to say, love you, no. Now, that's really funny and fascinating. I don't know how scientific it can be made to be, but say a little bit about this, how these dogs are picking words that seem to go into a sequence that says something.
Right. So after we could establish that they are paying attention to the words and they are listening to it, so from a comprehension point of view, the next question is, how are they using them? And in this case, we relied on a data set of about 21 months on 152 dogs. We looked at 250,000 button presses, which is a pretty large data set. And, for these individuals, we looked at the most obvious question, which is like, are they just pushing these buttons randomly, or do they seem to push some buttons more often than others? And luckily for us, that's what they do. So the buttons like food, treat, outside, play are pressed way more often than things like no, later, or love you, which is maybe what the owner might be pressing a little more frequently. So in that sense, they're not just matching, they're not random, and they're not matching the training that they received. The second thing was, with these dogs, they were actually combining some of these buttons in sequences, and we wanted to see whether these combinations were random or not. And when you basically compare it to what randomness would be for the specific buttons that they have, we realized that for the vast majority of them, they're not random. Now, notice some are random. It's not that all of them are amazing, but some most clearly are not random, which means that, when they push a sequence like want outside, it's not by accident that they put those two buttons one after the other. It's like that's the combination that they're using. And that's important for us because that's similar to what children do, right? So young children, when they get to about 50 words of their vocabulary, around 18, 19 months, they start producing two-word sentences, and people think of that phase as a very critical cognitive change because all of a sudden you have this combinatorial ability. Now you can communicate many more things, and it's very powerful. Of course, it's going to scale up to us being able to have this conversation, right? And so it was exciting, and yet the work is not finished, right? Because yes, it's not random, but is it purely mimicking the sequences that they were trained on, or is there more? Now, the guess is that there might be a little more, but that's sort of where the work is right now, and that's actually the analysis we're conducting on single individuals right now.
Now, this is fascinating stuff. We should say, as I understand it, that there's a very small percentage of dogs who will begin to develop really large vocabularies, being able to use a lot of buttons. Most, as you were just kind of suggesting, most of the dogs probably have somewhere between 7 and 10 buttons that they're really interested in because the buttons are connected to things that the dogs are really interested in. Do I have that right?
Yes. So this is actually an important message for everybody, which is like, not every dog is going to learn this equally, just like not every human is going to be very good at math, So there's huge individual differences. And so we have about 10,000 dogs, and the median number of buttons is 9. Which means that less than at least 5,000 dogs have fewer than 9 buttons, which is important to know. And some of them have none, right? They try to learn and they don't learn. But we also have about 60 dogs that have more than 100 buttons. And to me, that is interesting, right? It's like we need to check how reliable they are. I know some of them are pretty good. And it's like, well, what's happening with this, subset, a very small minority that seem to be able to learn more and use them a lot. And then the question is, are we finding some little Einstein here, or is it just something not that interesting? And so we want to look more into it.
Yeah, I'm not even sure I would want Declan to be able to say 100 different things to me. I have no interest in expanding his vocabulary that broadly. Federico Rossano, always very interesting to talk to you, Associate Professor of Cognitive Science at the University of California, San Diego. Thanks so much for joining us today.
Thank you so much for having me.
And to the rest of you, good audience. Audience good. Join again.
And you gave a wail, and then I was no longer alone, and I was no more a boozer. We'll make the happiest home. And I said, Lord, I'm happy 'cause I'm just walking my dog, singing my song, strolling along. It's just me and my dog, catching some sun. We can't go wrong. About your hating and your doubt, and I don't care what the politicians spout. If you need a companion, why just go out by the pound and find yourself a hound and make that dog get